Okay, so the big difference between combinations and permutations is that order doesn't matter. I just kind of explained that. So combinations is a selection of objects without regard to order. So if I have Basil, Trepat, and Abby, and they need to stay together, you guys become one group, and you, Basil, Trepat, Abby, so BTA is the same as ATB. Like, you're just still considered one group. It doesn't matter what order you are. Okay? There's a new formula. So this is the example. So PQR and S. So PQ, QS, and PRS and QRS are all arrangements. So the arrangement PQR and PRQ are the same combination. Like, it doesn't matter what order those letters are in. They're looking at those three letters. So this is the formula. It is on your formula sheet. So combination has a C in it, not a P. We know that N has to be greater than or equal to R. Same thing as a permutation. N represents the total number of possibilities. R represents what you're choosing. And R has to be greater than 0. We good?
Yes.
Easy peasy. Right. Okay, there are 12 females and 8 males in a grade 12 class. The principal wants to meet with a group of 5 students. Group of 5 students. So there's no restrictions. There's no restrictions on this. It doesn't say like 2 have to be females, 3 have to be males, anything like that. It just says students. So how many students do I have? 30. So N is 30. And how many am I choosing? 5. No, 30 on top. Sorry. Do you guys know you have a button on your calculator that will do this for you? I don't know if I did. Like, if you have a graphing calculator, probably Basil's calculator has it as well. Just let me grab my other little calculator. No, I have one on this one too.
Oh, I have one.
So look above my multiply and look above my divide. So permutations, combinations. There may be, no. The C, this NCR with the C's big in the middle?
I have a C on top of my multiply and an R on top of my divide.
You have a C on top?
And then an R. Oh,
we have everything. For us.
What do I do if I don't have it?
I don't know. You do the formula. Like, when in doubt, do the formula.
So it's 142,000?
Okay. So if I were to put this into my calculator, I'm going to put in 30, because that's my N. And then I'm going to go shift, divide, and it puts in my letter C. And then I got to put in my R, and so that's 5. Okay? No, because that's not who I am as a person.
Well, we can verify it.
But you can always verify it. It's always good to have that option, but my guess is you're going to have to do a binomial expansion in a non-calculator portion.
Okay, so what if it's not a calculator? How do you do it?
Okay, let's do the formula. This one you probably won't do just because the numbers are really big, but we would have 30 times 29 times 28 times 27 times 26 times 25 factorial over 25 factorial 5 times 4 times 3 times 2 times 1. So those cancel each other out.
What happens?
You with me?
Yep.
Go. Okay, so 5 goes into 30, 6 times. 4 goes into 28 7 times. 3 goes into 27 9 times. 2 goes into 26 13 times. So now what I'm going to be multiplying is 6 times 29 times 7 times 9 times 13.
And then you give us a calculator?
You wouldn't do this big one. I wouldn't put this on a non-calculator portion.
Okay.
But if you want to know how to handle it, it is the answer. For 142,506 possible different groups. That's a lot of different combinations. Okay, so now we're getting restrictions on here. So we need these two things to happen at the same time. So this is different than cases because we need 2 females and we need 3 males. So we need both of those to happen at the same time to create the group of 5. Does that make sense to you guys? So they have to be multiplied. So we're going to do the female portion first. How many females do I have? 12. And how many am I choosing? So I have 18 males, and how many of them am I choosing? So you're going to have to do it twice.
Imagine not having the button.
Did you try the button?
Yeah.
Did it work?
Yeah.
And how come, Cameron, did you try yours?
She didn't know where it was at.
Okay, how does everybody feel about that? I sort of simplified things when I did the formula.
I'm just talking to Oh, yeah, that's fine.
Is that fine? Do you guys know what I simplified?
The 12 and 2 and the 18 and 7.
Right. So I did the subtraction in my head, right? Because the formula states that they have to be subtracted. So I just did 12 minus 2 and I got 10 all by myself. All by myself. Do we want to use the calculator for this?
Should we know how to do it?
We do need to know how to do it. Everybody's like, but my calculator doesn't have that button. Definitely the calculator is quicker.
Well,
But quicker as a classic, let's complain.
I don't think we know how to do that.
are you going to know if you use it on the test too?
Well, if I take it away from you, I will.
Where's your 1 at? 3 times 2 times 4.
Sorry. What? Ooh, my sheet's loading. 53,856. Basil, did you use your calculator? Nice. Are you guys good with simplifying fractions like that? Like to divide into those things? You don't like it? Okay. Do the big ones, yeah. After would be 16. There? Oh, it should be 8, sorry. Look at that, it's an 8. Fixed it. Okay, one of the females is named Brooklyn. She has to be in the group. Brooklyn has to be in the group. We don't ask why. We don't. Wow. Okay, so Brooklyn needs to be in the group. How many Brooklyns do I have? One. One Brooklyn? How many Brooklyns am I choosing? One.
But we would have to do 11 now.
Okay, so now we're going to the group of females. How many females do I have to choose from? 11. Brooklyn. Brooklyn. Big ruiner.
Everyone likes her.
Oh, I need 2 males. Sorry. I need 2.
Can we do this one in our calculator?
Yeah, do this one in your calculator.
Okay, great.
It's still 2 females, even though you already picked Brooklyn?
Right, because we need a group of 5. 2 boys, 2 girls, and Brooklyn. Okay, what's 1 choose 1? 1 choose 1. 1. 1. You guys are mean. Ouch. Ouch. We said we were going to put this one in the calculator.
So what you said about the 11.1 classes
Doesn't apply to 11.1, it applies to 11.2.
I love it.
It's my favorite thing to do to you.
Yeah, and then it has third out of
When I don't show it? Okay. Okay.
Oh yeah. Wait, why is there a 0 on the bottom of the word?
What's 1 minus 1? Oh. Okay, am I good to flip? Yeah?
Wait. No.
We're never going to break this time.
I know, I'm just going to take a nap. It's okay. What am I doing, Tirth? What was wrong? That's next page. because we didn't space it out. Okay, so you guys know a basic deck of cards has 52? Yes? Okay. So let's talk a little bit about, just in case you're not familiar with cards. I know. So there's 52 in a deck. How many suits do we have? 4 suits. What are those suits? So we have spades. Maybe I'll do this. Let me find a different pen. Oh dear. I don't think anybody's going to appreciate that. Spades. Clubs. Hearts. See? Okay, so the other part that we know about it is that 2 of them are black and 2 of them are red. How many cards in each suit? 13.
Well, are we counting like any jokers or like extra cards? I guess not.
Okay, so if you have 52 cards in a deck and you divide it by 4, 13 is your answer. If you've played cards before with a standard deck of cards, you go ace through king, right? So 1 through 10 plus 3 face cards.
The only thing I remember from applies is
Deck of cards. Okay. All right. So how many ways can we deal a card of 5 a hand of 5 cards if there's no restrictions? A lot. I agree. So we're going to have 52 choose 5. 52 choose 5. Okay, are you guys okay if I just speed this up a little? Yeah, but we're going to use the formula to do some more complicated stuff. Okay, if the hand consists solely of spades. So we want spades only. So the choice of cards goes from 52 down to 13. And we're still dealing a hand of 5. So definitely a significantly less amount of possibilities for that, right? Okay, black cards only. 26, so it's going to be 26, 5. What?
In the formula, never mind. It's just confusing because in the formula, on the denominator, it's like R initial and then N minus R initial. So I was looking at that.
Okay, well, multiplication, you can do them in different orders. Okay. Thanks for the feedback.
You're welcome.
Okay, where is it that it's different? Oh, the formula sheet, okay. Pardon? Sorry?
It just didn't matter. Like, it doesn't matter.
Is the formula sheet opposite to mine?
In order, yeah.
Okay. Okay, so this one's a little bit more confusing. How many 4 of a kind sets do I have?
Can we just do like 4C1 and then 4
13.
Like that work?
You have 13 of them.
Oh, no, wait.
What?
Because you have 4 aces, right? So you have 4 of everything, right? So how many sets of 4 do you have? 13 sets. So we have 13 sets, and we want 4 of a kind, but we're talking in sets now. So how many sets do I want? Just 1 set.
Next time we put a question like this on the test, I can guarantee you I will be staying at your desk that entire period.
Perfect. Okay. I mean, you could do it out where you go, okay, I have this many aces, and I need 4 of a kind of that. So we're talking in sets at this point. So this is a set of 4. Like, that's what that is right there. So, but that's not a hand of 5. I need an additional, how many cards? I need 1 more card. How many cards do I have to choose from if, I heard it, I think it was you, Pablo, 48. Why?
Is this set of 4 being taken out?
Because it's a set of 4 that's been taken out of the total, right? So that's where you're at 48. What? I don't know.
You said why do we need 5? I don't get it. Like, why can't we speak in terms of 1 and move on? Oh, okay. See, I don't
And if you're playing poker, it's a 5-handed. It's a 5-card hand, right? So, yeah.
There's like no matter the order, there's 2.6 million combinations.
Yep.
Why is
See,
it?
I'm fully enjoying.
Well, that's assuming that you're playing with 1 deck. Like, I think Texas Hold'em rules is a single deck. But if you go to a casino and play at a table, they have multiple decks that they're dealing from. So then that becomes much bigger.
No, but you have 2 equations though. Or like you have 2 C's. Like,
Yep.
why do you have one with 48 on it?
Because we took 4 cards out because those were our set of 4. Okay, that's, you asked why I put 48 there, and it's because this group is a set of 4. So if I've already picked 4 out, then I just have 1 card left to pick that can be any one, right? So a set of 4, I've got 4 2s in my hand. I need 1 more card to make it to make it 5. Okay, so we have 13 factorial over 12 factorial, 1 factorial times by 48 factorial, 47 factorial, 1 factorial.
This gambling? Why would they do that? 18-year-olds start to go gambling.
What? I'm not teaching you how to
Oh,
gamble.
no. The safe platform was talking about like lotteries and other flies. I didn't even or like right on.
But like on a provincial exam, like when we were doing grade 12 provincial exams, there is no card questions on there. There's no deck questions on there because certain communities don't play with a standard deck of cards. Like I have a deck of cards that goes up to just 10, not like with your king, queen, and jack. And they're colored. They look like Uno cards instead of your black, white. I have a whole deck. It's very We'll play Dutch Blitz. It's actually quite a fun game. Have you ever played?
No.
Super fun.
Last year school said
Have you ever played Spoons?
Yes.
So you know how like it's like grabby and it's intense. You can't look away. That's yeah. There's been injuries.
let's play it on Tuesday. It says just don't do it exam review.
Okay.
Girl, go there on Sundays.
In how many ways can a committee of 5 be chosen from 10 conservatives, 7 liberals if there must be 3 conservatives on it? It's super easy. It's like the boys and the girls.
So do we do 23?
So conservatives, we have how many? 10 of them. And how many do I have to choose? Watch the language. Like this one, well, watch your language, but watch the language in the question too, because it's saying there must be. If it says at least, then we're going to end up doing cases. So language is super important here.
I didn't watch the video stuff on my
And then who makes up the other 2 seats?
Wait, so if it's must be, they can't have more than 3?
Right. So pay attention to the language. So they must have 3 on it. Not more, not less, but must have 3.
Are we putting it in our calculator or are we doing it?
Well, we'll do the expanded version just so we all know where we are. And then if you put in your calculator, Basil, what do you get?
Oh, I didn't do that.
So are you gonna give us the calculator?
Nope. Well, we're never going to make it through the lesson.
Okay.
Feel free to expand it in your notes.
Sure.
What is this?
Oh, you wanted it expanded.
But if I write it out, I don't write it.
Why is it 98?
There's a
Thank you. All my
yay. Okay, can you guys do the next one on your own? You're going to need a calculator though. Okay, have at her. Go. Because I'm getting to the point where I'm done. So you guys do number 4.
No, yeah, it's all divided up anyway. So
What's divided up?
it's divided up already. It's just like a curve. So
It is, yeah.
So we're on 4 C's.
Yes, you are. Yeah, because you have 4 different groups that you're pulling from. So you'll have 4 different Cs.
and then when we order, we add them.
Yeah, just give me the total. Oh, sorry. Yes. Yeah.
Is that like a group of 4 or like 4 individual teachers?
4 individual teachers. Yeah.
Is there a difference? Because like when there was the must be rule, it didn't change anything, did you?
We'll see how it changes in the next question.
But like what I'm saying is there was no must be rule, but you didn't do anything to change that. If it says must be, you didn't change anything. Like you just did it the same. That works?
Like I said, in number 5, you'll see the difference.
What kind? I don't
832,431,600.
But that's just specific though. I feel like I don't know how you have that many exactly.
Pardon? Well, it's different combinations of the group put together. So, like, when you think about it, like, so look at us, and if you change one person out of it, that's a new group. 832 million. Yep.
We finished ours.
So did you get that set up correctly?
But I didn't know how to do it.
Just right over 5, you can write down into the bottom of the page. 5 continues on the next page.
Can you try 5? What's the majority?
Okay, so question 5 starts on this page but continues on to the next one. What? Who? 600. Yeah. Oh, I didn't leave us any room to do 5.
But you did not do 5.
Well, it's kind of important. It's kind of important just because it's cases. We might be able to do it. We might be able to squeeze it in there. Okay, so this is about the language again. So how many ways can a committee of 7 be chosen of 10 women, 8 men, if women must be in the majority? So we have an odd number, right? So 7 is our committee. And so how many women represent a majority? 4. That's one scenario. Or 5. Or 6. Or 7. So we have to do each one of those as a case. So case number 1 would be if we have 4 women, and how many men would we have? 3 men. So because we have 2 different groups, we'll have 2 different Cs. Does that make sense? Just like this one, we had 4 different kind of groups of people. We had custodians, secretaries, teachers. So you're going to have 10 choose 4 times by 8 choose 3. What's case 2?
5 women, 2 men.
Right.
If it says they're in the majority, that means there has to be more women than men?
Yeah.
So it would be 9 then?
So still 10. So this is like, it's a whole brand new scenario. So you're still back to the 10, but this time we're going to choose 5 women, which means that there's only room for 2 men on the committee. That's an 8. I'm going to give you the totals just to save us time and space.
And then do we add them all together?
And then in the end, you're going to add them all together. So case number 3,
6 women, 1 man.
so 6 women, 1 man. So 10 choose 6, and 8 choose 1. And case 4, oh, sorry. It's just this base gets in the way. Case number 4,
7 women, no men.
7 women, no men. So do I need the second C? I don't. Okay, so what are we going to do with all the cases? We're going to add the cases together? Because all the cases can't happen at the same time. Or yeah, like you want to say possibilities or ways or, yeah. Yeah. Well, there's lots of space here. Lots of space. Okay. Okay, a committee of 4 is to be selected from 4 girls, 5 boys. In how many ways can the selection be made if there's at least, so that's the language again, at least 1 girl on the committee. Okay, so there totally could be 4 cases, but, so we have to have it, so at least 1 girl on the committee. There's a faster way to do this. There is a faster way. So on the committee, 4 people, there's a possibility you could do the total. Because, okay, you can totally do cases. So case 1 would be what? Case number 1 would be?
1 girl. Yeah.
1 girl, 3 boys. Case number 2. Case number 3. And case number 4. 4 girls, no boys. All right, so we could do the 4 cases and it would work perfectly. I'm going to show you a different way to do it though. It's the way we did it in permutations. There's a faster way to do it. I find the faster way is not super helpful. I like always doing my cases. It makes a lot more sense to me. But if you wanted to do it this way, you could take the total with no restrictions. And what would we subtract from it? So if you subtract the no girls, what's left is committees that have girls on them, right? So total restriction would be, with no restrictions, would be 9 people choose 4 committee members, right? And what would the situation be with no girls?
Why do you prefer the cases over this?
Well, this only really works for this scenario. I feel like other scenarios might not.
Boys only.
So I don't, this is not my go-to. Like cases make more sense to me because I can lay it out and see like exactly which scenario is happening. And that for my brain makes way more sense. This is way faster though. So it's, I want to show both ways. So if you did these cases and added them all together, it will be the exact same total as if you did it this way. So it's the reason why I wrote boys only is because you have to remember that you're only picking from boys. So it's going to be the 5 boys, and they're going to make up the entire committee. So that's going to be 121?
Yeah.
Okay, there must be more girls than boys on the committee. This one doesn't work using that same method. You have to use cases.
But there's only 2 cases, I guess.
But there's only 2 cases. What are the cases?
3 girls, 1 boy, 4 girls, no boys.
Right? Those cases that we listed there, if we had done them in question 1, we could use them to answer some of the other questions. Pardon? Yeah, I did. I'm sorry. Or like if it's a situation where it's one situation being removed, like one thing being removed. Here, because we have 4 and we're only removing 2, like it's not an all or nothing sort of thing. So we're going to have 4. So we have 4 girls and we're going to choose 3 of them. And we have 5 boys and we're going to choose 1 of them. And then for case 2, we'll have 4 girls and we'll choose 4. right? So this is case 3, and this is case 4. From that above list that we were working on before.
Wait, that's 5 orders, right?
Yeah.
Okay.
So 4, choose 3. Can we do that quickly in our heads? It's 4. So, like 4 factorial. 4 minus 3 is 1 factorial. 3 factorial. So that gives me 4. Okay, so this one here, what's that one? Can we do that one in our heads? It's 5. So this one was 4, this one was 5. So this one would be 5 factorial, 1 factorial, 4 factorial. So that's going to give me 20. Can you do this one in your head? 1. So 4 factorial, 0 factorial, 4 factorial. What's the value of it?
1.
What's the value of 0 factorial? It is 1. So how much in total?
21.
All right, so now we're jumping into algebra. Because that's how we roll. Okay? So we're going to replace that with the actual formula. So Cn choose 3 is going to be n factorial over n minus 3 factorial 3 factorial. You guys okay with that? And so what symbol is that in between them? Divide, right? So if I have n factorial, n minus 3 factorial, 3 factorial, divided by n minus 1 factorial, over n minus 4 factorial, 3 factorial. And that's the way I'm writing it. Instead of having a fraction inside of a fraction, I'm changing it to a division question. Because the next step is going to be multiplied by the reciprocal.
Why is exclamation mark by the n minus 3?
Because that's the formula? What can I cancel out right away, everybody? The 3 factorials. Let's just get those done and out of the way. So I can expand this one. I can expand the numerator over here. So it's going to be n times n minus 1 factorial. And I'm going to expand this one.
Where did the exclamation mark go on your n?
Because we expanded it. how do you expand 15 factorial over 5 factorial? How do you do that? Right? You're going to go 15 times 14 times 13 times 12 times 11 times 10 all the way up to 5, but you're going to leave 5 as a factorial on the end. So I did the exact same thing here with the algebra. So now what can I cancel out? Okay. Guys all said different things at once, but I like it. That's it.
There is no backspace.
Yeah, there is.
I know. Oh my god. I already got what I heard. You guys don't let me.
Okay. Am I good to flip the page? Yes. Good. All right. So this is the same sort of thing, but it's just we're multiplying this one by 2. Again, we're setting them equal to each other. So I've got 2 times n factorial over n minus 2 factorial equals n plus 1 factorial over n minus 2 factorial, 3 factorial.
I would prefer to
on the outside of the brackets.
It's just multiplied by 2. Okay. So looking at this, which ones am I going to expand?
Well, we can't have n plus 1 if we expand the n, so what's your point?
Well, we can expand that and get to this, and we can expand this to get to this. Right? So we're going to have 2 times n minus 1 times n minus 2 factorial over n minus 2 factorial. Your goal is to get rid of the factorials. So n plus 1, because that's my first term. And n would be the next one. And then we have n minus 1. And then n minus 2 factorial over n minus 2 factorial over 3 factorial. What are we going to cancel out? N minus 2, n minus 2. What else am I going to cancel out? The 2 factorial and the 2?
Oh.
Well, because what's 2 factorial expanded? 2 times 1, right? Hey, Miss Thompson. I'm still... Yeah, I'm here. Yep. Awesome. I'll take it home for a sleepover.
Multi-day this time.
Multi-day sleepover. It's so exciting.
Thank you.
Okay, so what am I left with now? So we have n squared minus n.
How do you get rid of the 3 factorial?
We haven't yet.
Can we? Oh, can we multiply it? Can we get 6?
Okay. We can get, okay, so you want to get 6 on the bottom.
You said to get 6.
Yep. So 3 times 2 times 1. Okay. So I'm going to multiply these two things. Why am I multiplying those two binomials before I multiply the n? Because it's easy. It's n squared minus 1. And n squared minus 1 times n is n cubed minus n over 6. Okay.
Not complex factoring. Oh my god.
Basil, what am I doing here? I got to move the 6.
So multiply that with 10.
Times both sides by 6. So I'm left with 6n squared minus 6n equals n cubed minus n.
So bring all the n's to one side and common factor.
Okay, so we're going to go this way though.
Yeah.
Okay, so 0 equals n cubed minus 6n squared plus 5n. Okay, we're not done yet. We're going to solve for n.
Common factor n.
Take out an n.
So 0, 5, and 1. Do we need to check these answers?
0, 5, and 1.
Can't we do? Oh, what? Oh.
No, I'm wrong. You're right.
Okay, yes.
You're right. It's 5 and 1. So my solutions are n equals 0, n equals 5, and n equals 1.
Are we checking these?
Any of those do I need to reject? Yes. Yes.
Does it have to be an actual number?
No, not the MPVs. What does n have to be?
Natural number.
It has to be a natural number.
0.
So right away, 0 is gone. What else does n have to be? It has to be bigger than r. Right? So that gets rejected. 1 gets rejected because if I put 1 in here, 1 would be smaller than 2, which is bad oh bad. Does 5 work? 5's good. So my only solution is 5. All right. Yep. Sure. Yep. Okay. Yep. Yeah. Okay. What? Yes. Basil? No, you can go after the bell because I'm not done. You can go after the bell and then come back and do the redo.
Okay, let's go.
You. Okay. All right. So this one here. This is Pascal's triangle. Is what this is.
I thought you had a wager on it. That's fine. Go.
Okay. So do you guys see the pattern in what I'm doing here?
Yeah.
Yeah? Everybody see the pattern? So I'm going up to, started at 4 total, choosing none of them, and going all the way to 4, choosing all 4 of them, right? If I choose none of them, what's my option? 1. Figure it out. Substitute it into the formula. If I have 4 things and I choose all 4 of them, how many combinations? 1. If I have 4 things and I choose 1 of them, how many possibilities do I have? 4. If I have 4 things and I choose 3 of them,
2. Oh, 4. Wow.
and if I have 4 things and I choose 2 of them,
Cameron's beating me. 8.
6.
Okay.
Okay, this is a line of Pascal's triangle. So Pascal figured out that using combinations, there was a connectiveness of numbers. And the way Pascal's triangle works is that you start with 1, and 1's become the sides of the triangle. So my next line would be 1 and 1. My next line would be 1, 2, and 1. My next line would be 1, 3, 3, 1. My next line after that, guess what you guys just found? 1, 4, 6, 4, 1. So that's called Pascal's triangle. He figured out that there was this symmetry and also all kinds of patterns in this. And that is your binomial theorem that's tomorrow. Because it follows this pattern. So always start with 1, end with a 1. The numbers in between. What's 1 plus 1? What's 1 plus 2? What's 1 plus 3? What's 3 plus 3? What's 3 plus 1? Okay, so there's all these patterns inside of it, and you'll start noticing So what would the next line be? We can do it without doing combinations. So it'd be 1, 5, 10, 10, 5,
Go turn. Okay.
1. What's the next line? 1, 6, 15, 20, 15, 6, and 1. There you go. There's Pascal's triangle.
Is that any use to anything?
It's tomorrow.